Alright, so today we're just converting radicals into what's called rational exponent form. So essentially it's just a power that has a fractional exponent. So we already know that the index is the little number that's over here. So let's say, for example, we have the fifth root of x. Right? We've seen this before. So you may see an exponent. It may either be inside here or right outside of the radical. So let's say it's raised to the second power. This is in radical form. If it's got a square root looking thing, then that's a radical. If you want to rewrite it in rational exponent form, your base is still x, and then you just make a fraction out of the 2 and 5. So it's x to the 2/5 power. So these are equivalent to each other. If you have it the other way around, let's say that you have y to the 1/3 power, this can be rewritten as y is my radicand, and then this 3 in the denominator, that becomes your index, and this 1 over here, that's your exponent. So it's the cube root of y, and you technically don't need the 1 because anything raised to the first power is just itself. So you're just going to convert to the other form in these problems. All right, so my base is 15. My radicand is 15, and I'm going to raise it to the 6/3 power. Now, if that can be reduced, you're going to reduce it. So 6/3 is equivalent to 2, and 15 squared, if you don't know what 15 squared is, then figure it out. That's 225. So the final answer is 225. If they can be simplified, simplify them. If not, you leave them like in this form. Okay, so my base is 10, and it's 10 to the 2/3. So this exponent goes on top. The 3 is my index. That goes on the bottom. Now 2/3, that doesn't simplify, right? It doesn't reduce. You can't take the cube root of 10, so you're good. That's your final answer. All right, here my radicand is just x squared, and so my base is x. I'm going to put the exponent on the top and the 7, which is my index, on the bottom. 2/7 cannot be reduced, so you are all done. All right, this one, it's a little different because you have a group that needs to be raised to the 4th power. So just like the other day, you're going to apply it to each part. So that number is a -1 to the 4th power. Then you have the cube root of 7 that also has to be raised to the 4th power. So what is -1 to the 4th? That's +1. So really, we can write down a 1, or we can just leave it off. And then this is 7 to the 4/3. So we'll just leave our answer as 7 to the 4/3. And 4/3 doesn't reduce, so that's as much as you can do. All right, so problem number 5, we've got 5th root of 9 squared, right? You could say 5th root of 9 squared. And my base is 9, so my exponent is going to be 2/5, because this is my exponent, and my 5 is my index. And 2/5 does not reduce, so we're all done. All right, what's my index in this problem? Remember, when you're missing an index, the implied index here is going to be a 2. So I'm going to write that in, because otherwise I think some people forget about the 2. So my base is 32, and it's 32 to the 3/2. And you can't reduce it, so we'll just leave that as our final answer. All right, number 7. We have this whole quantity raised to the 3rd power. So we need to distribute the 3, so it's -1 to the 3rd, and the cube root of 9 also has to be cubed. So -1 to the 3rd, we did -1 to the 4th earlier. If we cube it, that gives us -1. So it's -1 times the cube root of 9 to the 3rd, so we're just going to call this 9 to the 3/3. Now 3/3 is 1, so this is really -9 to the 1st, and -9 to the 1st is just -9. All right, this one we want to square our negative sign, and we want to do cube root of 27 squared. So we've got -1 squared, that's 1. The cube root of 27 squared, we can do 27 to the 2/3. Okay, so this could be your final answer because you don't really need a 1 there. Another way that you might see it is you could also do, like when we get to this point, the cube root of 27 is 3. So 3 squared is really 9. So you could leave it as 27 to the 2/3. That's fine, because it does say write each expression using rational exponents. But if you had to simplify it completely, You could also say 9. So again, this answer is fine. All right, this one we want to rewrite it as rational exponents. So we're not trying to simplify by pulling out the groups of 5 or anything. We're just going to write this is x to the 7/5 and y to the 6/5. So this index applies to both the x and the y. And 7/5 and 6/5 don't reduce, so we'll just leave it like that. All right, flip over to the back. If that was a little too fast for you, remember you can always go back and rewind the video and look at it again. All right, so this time we're writing each of these expressions in radical form. So you're going to be given this form, and you have to convert to this form. All right, so 6 to the 1/2. That means my index is the denominator. So I'm going to have the square root of 6, and that exponent still stays that way. So can you do the square root of 6? That's what it says, simplify when possible. Well, if you try the square root of 6, right, that gives you a decimal, so no. And 6 to the 1st is just 6. So another way you could write it is just square root of 6. And technically you don't need a little 2 there either. You just have the radical 6. All right, this is my index, so it's the cube root of 15 squared. So can you do the cube root of 15? All right, if you need to check, try the cube root of 15. That gives you a decimal, so no. But you could do 15 squared, so we could rewrite this as the cube root of 225. All right, this one, our index is 7, so it's 7th root of x to the 4th. And then can we take out enough x's? If we wrote out all of our x's, do we have enough for a group of 7? Well, no. So that's your final answer. All right, so we're going to keep going with these. My index is 2, so we've got the square root of 36 to the 1st. And what is the square root of 36? That's 6, and 6 to the 1st is just 6. If you don't remember, you can double check. All right, this one, always look at your denominator. Start there. So that's what your index is going to be. It's the cube root of 27 to the 1st power. So what is the cube root of 27? That's 3. And then 3 to the 1st power is just 3. Okay, the number 15 is 64 to the 2/3. So we've got the cube root of 64 squared. Right? So you should start getting used to seeing a lot of these numbers. You get a lot of the same values. So cube root of 64, hopefully you recognize that is 4. And 4 squared is 16. Now you could, if you wanted to, you could do 64 squared first and then take the cube root. But I would always do the index first. Like ignore the exponents and do cube root of 27 or the cube root of 64 first, because that always gives you that'll give you a smaller number to work with. I think it's a lot easier to do the problem that way. All right, so look at your index. That's the square root of 100 cubed. If I do 100 cubed, you get a really huge number. That's not worth it to try and then take the square root of that. So instead, just do the square root of 100, which you should know that one in your head. What times itself gives you 100? Right, that would be 10. Okay, so it's 10 to the 3rd, and then figure out what is 10 to the 3rd. That is 1,000. All right, this one, you're taking the cube root of your radicand is -8, so make sure the negative sign goes in there, and then we have to square that. So do what is the cube root of 8 first. Okay, think of what times itself. 3 times will give you, -8. That's -2. Okay, so this value is -2, but then we have to take that quantity and square it. So make sure that you have the parentheses here, right? Because this answer is not the same as doing this answer. So you get 4 as your final answer, +4. All right, and then last one's the square root of 9 to the 5th power. All right, so can you do the square root of 9? Yeah, square root of 9 is 3. And then what is 3 to the 5th? It's 243. All right, so double check all your work. If you have questions, make sure you write those down and ask us tomorrow when you see us in class.